recording now. Now it's recording. And let's take a look at this video, and then I'll try to find out where the others are. Hope. Sorry about that. Okay, good. What do you think about it? The others. I like that. Nothing to be ashamed of. Then there's some commercials. Just a moment. I'll just keep that commercial here. Okay, there we go. So, yeah, professional, right? Pretty good job. Well done. At least passing grade. Nothing to be ashamed of. And for you two, it was the first time you did the. It was first time on video for you. Well done. Definitely well done. Okay. Any comments? How was the Japanese? I didn't understand it at all. That's why I'm asking. I think it was good also in contents-wise. Okay, good. Clear. Now you understand what the project is all about, right? Do you think that your grandparents would understand it? Right. Yeah, clarity. Excellent. Yeah, well done. Okay, let's take a look at the other one. Yeah, it's the same one. Oh, sorry. Sorry. Sorry about that one. Mhm. that the same? Again, the same. Sorry. Yeah. I'm trying to get this from the that sheet. Control click. No. Control C. There we go. Da-da-da-da-da-dum. That's supposed to be different, right? Maybe. Yes.
So how I will be implementing this kind of system is by using something called a gamma filter. It's a mathematical model or a filter that is widely used around these kind of problems in robotics and in various places. And what this does, in principle, it's very simple. It can take in multiple, in a multivariate situation, it can take in multiple data sources, or for example, multiple estimates for one estimate from laser data and another estimate from GPS data, as illustrated in this image. You can see here plotted on X and Y, kind of two-dimensionally plotted two estimates with the different colors. And these estimates both have a mean and a covariance. The covariance is the kind of size of the oval. And what the gamma filter in this situation would do is take these two estimates and create a new estimate that, as you can see, hopefully has a much larger variance than the initial two estimates. So basically it's used to combine this data and create this more accurate version. In practice, what we would like to do is go from this kind of inconsistent estimate you see here in orange into this consistent estimate, clearly more accurate estimate you see in blue. Okay, that has been my presentation. Thank you very much.
Okay, comments. That was clear. Is your grandfather engineer? Okay, good job. That was clear for engineering student, but for being countered, that would be way too more complicated. Too much technical detail, but otherwise, technically this is excellent presentation. I like this kind of calm voice there, narrative voice. Also, these graphs are clear. but basically the content is very technical. He will become an excellent engineer. Okay, but for the say next time you're making video, think more about the audience. That's my comment. Anyone else? Any comments? Okay, good. Yeah, it was nice. It was nice. All right, let's take the next one. Next. Right, let's see. Who will be blushing this time?
Hello,
There we
my
go.
name is Shohyose. I will talk about my project, development of an intelligent dialogue agent for older adults using smart speaker. First, here is called smart speaker. These can be bought at electronic stores, and recently more people are installing at their home. As you can see from the name speaker, sound come out. However, unlike ordinary speakers called AI, artificial intelligence is installed. It can understand the language and solve some problems. For example, when a user asks a question like, "Hey Google, how is the weather today?" the speaker can answer, It's sunny in Tokyo today." Similarly, smart speaker provide a lot of information such as news. On the other hand, in Japan, the rate for people whose age is 16.5 and over is 28.1% at October 2018. And also, Japan is known as the world's most advanced super-age society. So preventive care approaches have received a lot of attention as they aim to decrease the number of people who require nursing care and human support by reducing the decline in individuals' mental and physical functions. We have developed an agent called Intelligent Dialogue Agent. It aims to continuously to use the system through active conversation and to watch older adults. Smart speaker can easily enjoy conversations. However, general smart speakers do not speak spontaneously. So, in this project, it was possible to speak without request from the user. In addition, I want to make natural conversation with the intelligent dialogue agent like chatting possible. Even if you are told at night that it will rain in the afternoon, you are not happy at all, alright? In this case, the agent should say in the morning. These were people in the world who love talking and not. I want people to adapt the frequency of conversation with the agent. You want to be called, "How was your day?" when you are going home, isn't it? Moreover, the agent can speak about their daily routine such as notification at regularly or fixed time, enable to adapt the speech content to users. In this way, we are developing intelligent dialogue agent. It's aiming to take part in natural conversation with its users. That is all. Thank you.
新人の
Okay. Sure, it's not here. But then, any comments? Yeah, that was a nice presentation, I think. At least I partly understood it. Yeah, and there's actually an increasing need for that kind of say machines, robots, artificial intelligence for elderly people like me in few years, say 20 years from now. I want to have a robot with me. The next link, I'm not sure if it works actually. It's a edit link to studio. Nope. Yep. So it does not work that way. Maybe I can actually guess the link. That's the. Okay, it does not find anything matching the. Let's go to YouTube. It's the video. No. Okay, so the one of these links did not quite work. Hmm. Hmm? Yeah. Yeah, with that code, maybe. Let's see. U2.be, yes. Hmm. Like that. Why not get the. Not copy paste. Does not copy paste for some reason. Nope. Nope. Link is not working. I will just send email. Email at some point. But anyways, good job this far. I will show you actually one more link which I checked yesterday. Yesterday, just to give you some idea that what kind of environment to use on the videos. On the other hand, yesterday you basically didn't have much choice. It's within the campus, more or less. But just a moment. Yesterday I was also getting one of these final year projects. Final year projects from Konstantin. From one of my students. There we go. It's already an unavailable, of course. Of course. It's not anymore available since I gave him passing grade, so he took it out. So basically, there was one video about which was actually shot in home, so that you have a screen there, and then person talking here, and one having the camera on a really, nice and cozy chair. And it was so relaxed environment. It was basically setting up a totally different kind of mood from the, say, taking the kind of the official feeling out of the video and having more like relaxed kind of environment. So just to think about on your next videos, what you will be doing constantly. Think of also the environment. Play a little bit about the environment. Some years ago, I was kind of in a situation that I had to make a short 2-minute video to the start of a conference which was about emergency health care. Okay, emergency health care conference that the conference itself was somewhere in Europe, and I was asked to give a 2 minutes welcome speech on internet on that one. So I used one half day to make it, and I actually shot it on my front yard. So there's it's kind of middle of nowhere, lots of green stuff there, growing flowers, such kind of things. And it was about emergency motor, the conference, and with a special topic on the road accidents. And I turned my camera, took a selfie like that, and at the end there was my motorbike and my car behind me. So, so that gave the kind of glue to the that emergency conference and asked them to keep the roads safe. Okay, so think also the environment. Use the environment if possible to make the message clear. Okay, but anyways, good job, good job. There was one email actually also about the Ilpo. Yes, yes. One more.
Hello, my name is Max. My research is processing and its effect of learning parts of micro robot adding micro texture。ここから日本語に切り替えますね。
Okay, yeah, we'll
マ
see.
イクロロボットの走行部におけるマイクロテクスチャ付与の検討とその効果っていうのを研究しています。で、発表用紙としてはマイクロロボットの現在活躍が広がっているんですが、悪路での走行性能の向上が課題となっています。で、この研究ではタイヤやクローラー部分にテクスチャ付与をすることでその改善を試み、実際の付与方法やその効果検討を行っていこうと思っています。で、マイクロロボットっていうのは、大きさが 1mm 以下の事実可能な超小型ロボット、またはマイクロメートル単位の物体を扱えるロボットのことを指します。一般にはそのマイクロという言葉が小さいことを指すため、混乱を避けるために大きさによって分類することがされています。で、マイクロロボットの活用場所なんですが、そのピラミッドの中の穴に入っていってその中を探査したり、その災害現場やその福島原発のようなその瓦礫の中に入っていってその中を検査したりっていうのがあるんですけど、それ以外としてはその工場の中の配管などを通ってその中の状態を検査したり、水道管の中を検査したりとか、そういう検査目的のものが多いですね。で、最近では、Wi-Fi のような無線技術、通信技術が登場したことでマイクロロボットの通信能力が向上してきています。これによって複数のマイクロロボットが相互に通信しながらより複雑な作業を課すことが可能となってきたりしています。で、残りはそうですね、マイクロロボットと微細技術のことをメムスっていうんですけど、メムスっていうのはマイクロエレクトロメカニカルシステムの略で、機械要素部品、センサー、アクチュエーター、電子回路などを使ったシリコン基板、ガラス基板、有機材料などのように微細加工技術によって、集積したデバイスのことを指しています。で、マイクロロボットなどもこのメムスに関係していて、これからの時代により発展していく分野だと思われています。
Okay. I had no idea what actually was there on the contents. Hiro Sensei, would you help me on that one? So it's about micro robots, and they was mentioned the MEMS. What is the size of these robots? There's a picture of big, but that was not micro; it was mini. Oh, less than 1 millimeter. Okay. Not here. Yeah. Yeah. Less than 1 millimeter. Okay, then you need basically MEMS. Okay. Okay. Inside of those. Yeah. Okay. Yeah. 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 Yes. Hmm. Okay. Okay. It was very technical, and I would guess that's a typical presentation. Typical presentation. Yeah, technical, and another thing, I mentioned this one actually yesterday, the comment that, okay, think of your grandparents. So would they like to read, or would they like to see nice pictures? So I would have liked to see the pictures because I don't read or understand the Japanese. So basically for that reason, but I would guess that would make a big difference. So since I know that in MEMS world you can make really fancy pictures that are really something. Just like there are some those devices are so small that you usually need to use some special imaging tools for those, like the electron microscope pictures and that kind of stuff. That makes everything look cool. Yeah. Okay, but that was a nice video. All right. Where's my mouse? Here. Okay, that's not the one. Good. So that part is done, at least for you guys. I'm still waiting. You can still actually return those exercises. Let me show you how. That's quite simple. Sites. That's the Innovation Project Japan. There we go. And on each of those exercises, there's also a link to return the exercise, which is just a form like that. And there's the space for the names of the group, if it is group work, or the name of the who was doing it, email address. Basically, if there is something wrong with this return, then I can send you email. That's the reason. Then exercise number of, sometimes I kind of, okay, so I have more or less everything here. So sometimes I don't have a, I have less than the number of exercises in the form, but anyways, this looks like okay. And then you just put the link, URL of this return. So the video link, that would be the URL of this YouTube video. If it's something else, a document, then you would put that document somewhere on the internet and provide me a link. For example, Google. If you use Google Docs to make the document, then you can make the share link for that one and put it there. Okay, so that's how you return an exercise. And yes, you can return the exercise also a bit late. I will find a good way to punish you for late return. Good. All right, so today's topic was about timetable, and not just any timetable. Timetable is basically just a schedule for the project, but that's a little too big. But timetable actually for a project should have the following phases at least. So it should have the research phase marked there. So you need to do some, whatever you start doing, new or old stuff, you will always do some research on the topic. For example, the last video was about these micro robots. You probably would need to go through some micro electromechanical systems literature. So that's already working time for the project. So even before the project itself starts, or actually you will be starting the project by doing some research on it. Okay, then the design phase, meaning basically, okay, what is on the research, at the research phase, you basically have a question, a problem that you want to solve. And on design phase, you find a solution for that problem. And next type, the phase would be the prototyping. You will find out basically probably using some fast prototyping tools to what kind of approach would be appropriate for this. So you test your design ideas. If it doesn't work, you go back to the drawing board and continue design. So basically the prototyping and design, it's more like a circular thing. And next, when you have fixed the design, test it with the prototype, then you go to the operating mode, meaning that you will collect some user experience. That's the normal way of doing things. And then finally, okay, documentation, although it's marked there at the end, it should be done continuously at some level. At least those. For the creating timetable that anyone can understand, anyone working on project can understand, basically I recommend you to see what is Gantt chart. Have you heard of Gantt chart? Maybe the Finnish students should have heard about it. Gantt chart. All right, so let's see. That's a Gantt chart. So it's basically, it has this. Tasks of a project is broken into tasks and subtasks. And then basically you put a timeline of that one in graphical sense. That I think is made by Microsoft. Yeah, it says there. Microsoft Project is one tool to make Gantt charts. It's graphical timeline for the project, and that's basically the most important tool for the project manager that you will be one day. If you do a good job, good jobs are always punished somehow, and the punishment is to give you a project to manage. Okay. Yeah, someone has to do it. If you do a project really well, it usually means that the next step on your career, meaning some more challenges and more responsibility and more salary, you will be given a project to manage. You will be a project manager, meaning that you really have to be able to read these kind of things. You need to be able to create the timelines on Gantt charts, and you need to use those during your project. Okay, that's one example. There are plenty of examples of Gantt chart on the internet. You just need to browse, and there are also lots of literature also on this one. Lots of references. You can find basically any project management 101 book has a chapter about the Gantt chart. If it doesn't have, don't read that book. It's not really giving anything for you. So fundamentally, what I would like you to do for this project now is to make a Gantt chart. Just a moment. I see. It has two ends. The other end hasn't just been taken to use. So does it? No, it doesn't have that. Stupid pen. Okay, so basically, when did you start your project? That was 1 month ago or 2 weeks ago or something like that. When did you start it? 2 months ago. No, it's on beginning of October or something like that. Right. October. November. This okay. No, I made a big mess already. So on Gantt chart, you should have actually the task written on here, and then you have the timeline from November, October, sorry. October, November, December, January, February, and beginning of March. So basically we have March 4. March 4 is the deadline for everything. So that's your timeline. You already know what you did here. You probably did the research part and that kind of stuff there already on October, and went to the design, prototyping. This is just an example. In your case, it could be also the software design, hardware design separately, hardware, software, which are the subtasks of the design. And okay, on the design, you would also have the software, hardware, integration design, integration, and closure, so enclosure, the box, box design, and then the prototyping or testing, and then or usage test. And now your task is actually under documentation at some point, of course. Your task is now to basically go and fill the blocks like, okay, here you had the hardware design started, software design at the same time, maybe then at the integration. At some point you would think about the box, but not yet since you don't have this one done. So after those, you probably, after you have that integration done, you go to the prototyping and back to design, either hardware or software or whatever. How many loops you think you need after prototype? You might actually then go final design, or after the final design, you would go to usage test, and basically at some point here you should have the box somewhere in between here, the first version of the box, meaning cardboard, duct tape. Yeah, you can do a lot of things with the cardboard and duct tape. This is engineering, you know, or 3D printing, final box. Okay, and documentation, when the documentation happens. Well, research should be documented, right? All of these design phases, when they are done, you should document it. Basically, after you had done the prototyping, you should do also documentation. How did it go? Is this your final? What must be done differently? When you have the final, you would do some documenting. After usage test, you will do some documenting. And of course, at the end, you should do a lot of documenting. And documenting, of course, you can then make these two into subtasks called report. You need to do also the poster. You need to do the video demonstration. So maybe here you have, after the usage test, you would have the video. Report, you would basically do somewhere here, maybe poster somewhere here, maybe tweak your video. But anyways, that's just an example how to make the Gantt chart. Most importantly, it has the timeline and what happens when. Okay, and do it today. I will be here and checking at the end of today at 4:30. I'll take a look at your timelines and check marks and give you some advice. Usually, there are not really mistakes made since you will be doing the project. It's your tool to take care of that the project will be finished by March 4, which is the ultimate deadline. The presentation. We are shooting for this presentation. You can actually go forward with this Gantt chart and mark the presentation on March 6 or whatever that is on that conference. The conference presentation is your last day. This is just the checkpoint for that. And then, okay, try to make sure that, for example, here, usually nothing happens. At least in Finland, at the Christmas time, you lay back, drink beverages, eat gingerbread, pork, the Finnish kind of ham, stuff like that. You are rewinding, nothing else happens. So that, of course, don't put anything there. So one way to ensure it's that you will first fix the dates that nothing happens. And then you can actually start seeing that how many days you need for each part. Okay. Calculate the rough estimate also for the how many working days. For example, there's it's basically very accurate description or duration of how many working days there are on this Gantt chart. So that's also should be included somewhere. For example, here, so working days, research done already. How many real working days, not the calendar days, but how much did you do the research? Be honest to yourself. If you see that there's too little number of hours done for the research, then you know what to do next. You need to fix the situation by putting some more research here. The total amount of hours what comes out since you are doing a bigger project here, it must be more than 270 hours. Otherwise, I don't believe you. Well, that comes from the fact that this is 10 ECTS project, basically the innovation project, and you are doing this full time, more or less. Do you have any other classes going on? No, not really. You're doing just this project. So, okay, it's much more than that. It's 1, 2, 3, 4, 5 months, 4.5 months, something like that. How many weeks is that? That's something like 700 hours or so. You should be working on your project. Okay, so yeah, so today's task is to do this assignment number 2, which is the Gantt chart for your own project. And remember, this will help you to manage your own project. I'm just here to help you so you can actually fix those days and timeline to yourself. You are doing this exercise to yourself. You are the main stakeholder for this information. In real work, you would be the project manager doing this one for the whole project group. Ha! So have you done any of these yet? Yeah, timetables. Okay. Okay. Yes, yes, yes. Yeah. This is a good exercise. Okay. Good work. I will be here until 4:30, and then at 4:30 or a little bit before that, when you think you have the timetable ready, can take a look at it and mark that you have done it. I'm not that much interested about the content of it. I just try to make sure that it makes sense. It's really kind of it's graphic presentation. It's really fast for me to look at. I have been watching those, for the last 30 years or so. Good, good work. Pen and paper is good start. You can also use this one. You can use the whiteboards, pen and paper, computer. If you have Microsoft tools there, yeah, Microsoft Project is a nice tool. At least the Metropolia students have this as a package, Microsoft package. I think you need to download it separately, but you have the license. The Tokyo Kosen students, I don't know, but there are these free online tools also with some advertisements, of course. But you can build it on any spreadsheet also. You just need the, to do the timelines and some kind of the arrows here and there. Okay, that's my part for today. Any questions? If not, good. Thank you for attention and start working.